Hello, my name is Sean, and today I'll be going over RSA Cipher. So, for this particular one, it's a very math-heavy RSA Cipher, so I'm also going to grab a calculator. Some interesting values. Alright, so what we're going to actually grab is the variable being n, so that's 2491. We need also e, which is going to be 773, as well as the 6 numbers down here on the bottom screen. These numbers represent our encrypted word that we need to decrypt these numbers to turn them back into an actual word. 322, 168, and 1780. Okay, and 1, yep. Alright, to start off with, we need to get lambda n. So in order to do that, first we need to figure out what two prime numbers were multiplied to get this value of n. And there's some tips and tricks with this one. If the value is like less than 4,000, start on this end. If it's above 4,000, start on this end, basically. So I'm going to start off here because the number is rather low, so 2491, which I'm just going to copy here. We're going to go through these list of primes to figure out what this is being divided by. Nope. 19, 23. No, divided by 23. Divided by 29. Nope. Divided by 31. Nope. Divided by 37. Divided by 41. Man, this is actually pretty long. There we go. Yeah, it's somewhere down the middle if it was 2,000. Maybe I was wrong to say start over there. But anyway, so we have our first number being 47 and the second number being 53. Those are our two prime numbers. And what we're actually going to do, once we do that, we're going to use this equation down below, which is we're going to take prime 1 minus 1, so we're going to take 46, and then we're also going to multiply this by prime 2 minus 1, so this would be 46 times 52, which is a pretty easy thing to do. So 46 times 52, let's give us this number. So this is 2,392. And this is all going to be divided by the greatest common denominator, or GCD, or greatest common divider, of prime 1 minus 1, which is 46, and prime 2 minus 1 of 52. So we need to find the greatest common divider or denominator of these two values. To do so, what we're going to do is we're going to take the greater of these two values and module it by the other number. So 52 module 46. This is going to leave us with a value of 6 in this case. Then for each one, we're going to take the number to the right of the equation and module by the resulting value, which is 6. I'm going to figure this out. The only thing I can think of is 42 in this sense. So with that, in that case, I think it's it, because 5 times 8 is 40, and then 6 times 8 is 48, and then 48 minus 6 is 42. So 46 minus 42 is 4. 6 module 4 is going to equal 2, and then for module 2 equals 0. And when we reach the value of 0 here, that means we're basically done. And the value, the greatest common divider, is going to be the value right in this spot right here, which is the right number of the last operation when the result was 0. So now we know that the greatest common divider is 2. So I'm going to take this value, divide it by 2, I'm left with this value. 1,196. This is lambda n. We don't need the primes anymore, we don't need this anymore. Next, we need to figure out D. In order to figure out D, we're going to set up 7 variables, being A, B, Q, R, T1, T2, and T3. There we go. So, at the very start, A is going to equal to n to n. So 1,196. For B, we're going to set this up equal to E, being 773. Then we're going to take the quotient of A and B, which is 1,196, divided by 773. Rounding down gives us 1. Then we're going to take the remainder of this operation, so 1196 modulo 773 gives us a 423 as our remainder. Next, we're going to set up T1 equal to 0, T2 equal to 1, then T3 is equal to T1 minus the product of T2, which is 1, times the quotient, which is 1. So 1 times 1 is going to equal 1, and 0 minus 1 is going to equal to negative 1. Now for every iteration we're going to be doing this process. We're going to set A equal to B, so this becomes 773. We're going to set B equal to the remainder, which is 423. Then we're going to do A divided by B, so 773 divided by 423. Round it down, makes it 1. That's our new quotient. And our new remainder is 773 modulo 423 is going to be 350. Then T1 is going to be T2, T2 is going to be T3, and T3 is going to be T1 minus the product of T2, which is negative 1, times the quotient. So negative 1 times 1 is negative 1. So 1 minus negative 1 becomes 2. All right, let's keep going. And we're going to keep doing this until our remainder is 0. So now we set this to B, 423, and set this to remainder, so 350. Then 423 divided by 350 is going to be 1 in this case. Then we're going to take 423 modulo 350. This gives us 73. No, this should be 1. Remainder should be 73. T1 becomes T2, T2 becomes T3. And T3 is this, minus T2 times the quotient. So this becomes 2. Negative 1 minus 2 is negative 3. This becomes 350. This becomes 73. The quotient between the two, so 350 divided by 73, is rounded down 4. And 350 modulus 73 is going to equal to 58. So this becomes T2, T2 becomes T3, and then T3 is 2 minus negative 3 times the quotient, which is 4 right now. So the quotient, this is going to become negative 12, and 2 minus negative 12 is going to be 14. Okay, this becomes 73, this becomes 58. So 73 divided by 58 is 1, and 73 modulo 58 is 15. This becomes T2, this becomes T3, then it's negative 3 minus 14 times the quotient, which is 1. So this becomes negative 3 minus 14, which becomes negative 17. Then this is going to be, this turns into 58, this turns into 15. Then we have 58 divided by 15 is going to be 3. And this is 58 modulo 15 is going to be 13. This becomes 14, this becomes 17. This becomes 14 minus negative 17 times the quotient, which is 3. So I'm just going to do 17 times 3. It's going to be 51, and considering this is going to be a positive when this enters, I'm going to add 14 to this, giving us 65. Okay, this becomes 15, this becomes 13. The quotient between these two are obviously going to be 1. The remainder of this is going to be 2. T1 becomes negative 17. This becomes 65. Then negative 17 minus 65 times the quotient, which is 1. So that becomes 65 minus this. So I'll do 65 plus 17. This is going to give us negative 82. So next, this becomes 13. The remainder becomes 2. So the quotient of this is going to be pretty, 13 divided by 2 is going to be 6. The remainder is going to be 1, because this is just simple binary, because it's either going to be a 0 or 1 when it comes to 2. So then we have, this becomes 65. This becomes negative 82. Then this becomes 65 minus negative 82 times the quotient, which is 6. So we need to do 82 times 6 in this case. It's 492 plus 65. This is going to leave us with a result of 557. 2 times 6 and plus the 65. So this is 557. Alright, we still don't have a 0, so this becomes 2. This becomes 1. The quotient between the two is going to be 2, and the remainder is going to be 0. Now, if you step by this step right here, which is basically 12, the value that is equal to d at this point is going to equal to t3. Now, if you kept going all the way to 15 at this point, then the new value becomes t2. Because when we actually go to the whole sequence, this becomes negative 82, this becomes 557. You see after step 14 that our d value is going to be t2 instead of t3 in this case. But in either one, our d value is going to equal to that value, which is 557. And this 557 is going to be modulus by lambda n, which it already is. If it was negative, then you obviously need to modulate it, so it becomes a positive value. Now, one great thing to check if you're actually right at this point, for step 2 at least, is by taking d, which is our 557, and multiply it by e, 773, and then we're going to modulate this by lambda n, 1196. And if you get a result of 1, that means you did step 2 correctly. However, that doesn't mean you did step 1 correctly. That's all I'm going to say about this, because you can do step 1 incorrectly and still come out with a result of 1 in step 2. And all that's going to mean is you're going to get gibberish for step 3, which makes this a particularly difficult module. If by that point, if you got step 1 wrong, then you need to do the whole entirety of step 2 in order to do step 3 again. Now, time to do step 3. And for step 3, we're basically going to go through this process of doing this equation right here. In which case, P, what I'm going to get rid of, that's going to be our plain text letter. So we need to subtract it by 1. Our n here is going to be this right here, so 2,491. C is going to be whatever value that we have here for any of these numbers here, which is 9. And this is going to be to the exponent to the power of d, which is 557. So, as you can see here, this results in a very huge number. So, let's say in case if you don't have a powerful calculator like this, because I can simply do this equation by simply copying and pasting, and it gives me the answer right away. So let's say if we don't have that luxury, what do we do with something like this? Well, if you don't have a power enough calculator, first we need to convert D into binary. So to do that, we're going to look at 557. If it's an odd number, which it technically is always going to be, we're going to set it, we're going to have a 1 here. Otherwise, if it was even, we would have put a 0 instead. And then we're going to divide it by 2. Rounding down, obviously. Now, if this is an even number, we're going to place a 0 now. Divide by 2. This is an odd number, so we got to place a 1. This is an odd number, so we got to place a 1. This is an even number, so we're going to place a 0. This is an odd number, so we're going to place a 1. This is an even number, so we're going to place a 0. This is an even number, we're going to place a 0. This is an even number, we're going to place a 0. And finally, this is an odd number, so we're going to place a 1. And once we get to this point, you can stop because when you divide it by 2, for all cases, it's going to be zeros throughout because they're all going to be even numbers. Because 0 divided by 2 is going to be keep recycling 0, 0, 0, 0 all the way. So by the time you reach 1, and you place the final 1, and that's practically it. So now we have our binary. And then what we're going to do is starting off with our cipher number. And then you're going to do this for each of these numbers. We're going to start off with the cipher number, being the first one right here. Then we're going to take 9 and multiply it by itself. And then we're also going to modulate it by n. Now, 9 times 9 is 81. So that's going to be our next number for that. Next, we need to take this to the 2 power. That's going to be 6,561. We're going to mod this by 2491. I'm just going to copy this value anyway. 2491. That gives us 1579. Take this to the power of 2 and modulate this by this. This gives us 2241. So unplug this for a moment. Then I need to take this to module 2. And then, no, I want 2241, power of 2, module by this. This gives us 225. And then we gotta do this. 805. 365. 1202. 24. And 576. All right. Then we're going to grab all the numbers that have a 1 in front of it, which is this 9, this 1079, this 2241, and the 576, and we're going to multiply all of them together. So first I'm going to do 9 times our 1579, and we're going to keep modulating this by the same n value every time we multiply these together. So now we're going to times it by 805. Module by this, that's 1000, and then times it times by 576, and I think I missed the value. Yeah, I think I missed the 2241, right? Yeah. And that gives us a value. I didn't know I missed the 2241 until after that. And so this gives us usually a value between 2 and 27. And all we did here is we basically did this process up here, which is the number to the power of delta module n. That's basically what that whole process was. And then we're going to subtract this value by 1 now, which gives us 16. And now we gotta turn this into its alphanumeric position. So P16 would be P in this case. I'm only going to do that once because I feel like doing all that once was necessary to know like what you're supposed to do. And then you do this whole same process again using the same binary string here. But now you're going to use 225 for it instead of 9 as the starting number right there. But because I have a power enough calculator and stuff, I'm going to simply copy and paste all this. This is going to give me 15, that's an O. So this is 1097, copy, paste. This is 5, that's an echo. This is 132. Is 20. 20 is T. One, 168. It's 18. 18 is R. Finally, we have this. That is 25. That's a Y. And we spell out the word poetry. And to submit your answer, you start typing on the keyboard. And you'll notice on the bottom here, it will start typing. So Poetry. Now, another thing you can clear out if you made any mistakes using this red button. And then to submit your answer, you just simply press this green button. And that's all there is for this module. A lot of math and all that. Now there is something interesting, which is the reference to Hill Cipher. There's a reason why it does this, because of this step 2 right here. Now, when I said if you did everything correctly, the product of D and E, module M to N, should equal 1. So basically, D times E module lambda n, which I can't really do, I'll just do n, equals 1. Something about this should be very familiar. If you don't, I can start replacing n with 26, for instance. And then I can replace d with n. And then what I'm going to do is I'm going to replace e with AD minus BC. And as you see right from here, this is the Hill Cipher equation. And it is exactly how it is. So, if you do the extended Euclidean algorithm the same way you do for Hill Cipher, you also get the same answer. But of course, I feel like doing it that way for Hill Cipher is very time consuming. It's rather better to start guessing numbers to figure out what 1 is. But the reason why I included this is, well, as you see beforehand, D was a huge value, being 557. So now the question becomes, are you going to go through this process about 557 times just to reach an answer? Probably the answer to that question is no, which is why I included this algorithm, to make things a little bit easier and manageable to actually do it. So I hope all of you enjoyed this tutorial. Oh, and one last thing. If you type in, say, anything, it won't reset anything at all. It will just keep the same answer and all that stuff. So, if you enjoyed this tutorial, you know, I hope all of you enjoyed this tutorial. And until next time, guys, keep talking and don't explode.